Okay, so the last part of this section is hyperbolic trig. So what are hyperbolic trig? Well, there are two that we're going to work with. We're going to work with hyperbolic sine and hyperbolic cosine. So those are the two. Now what are they by definition? Hyperbolic sine is written as sine with an h. It's just a function, kind of like sine is a function. So hyperbolic sine of a number is just e to that number minus e to the negative of that number divided by 2. Okay, so for example, what is hyperbolic sine of 0? That's going to be e to the 0 minus e to the negative 0 over 2. So let's see, e to the 0 is 1, e to the minus 0 also 1, so I get 0 over 2, which is 0. So hyperbolic sine of 0 is in fact 0. The other hyperbolic function we're going to look at is hyperbolic cosine, which is cosine with an h, so that just means hyperbolic. By definition, this is e to the x plus e to the minus x over 2. Now, for example, what's hyperbolic cosine of 0? That's e to the 0 plus e to the minus 0 over 2. E to the 0 is 1, e to the minus 0 is 1, so I'll get 2 over 2, which is 1. So here are my two hyperbolic functions. By definition, hyperbolic cosine is e to the x plus e to the minus x over 2. Hyperbolic sine is the same, only I have a subtraction. So those are my two hyperbolic functions. Now, the nice part about these two functions is that when you look at their derivatives, you could find the derivatives using a quotient, or you could break it up as two different parts with a 1/2 as your coefficient. If you find the derivative of each of these, you'll see it bounces back and forth. So the derivative of sine is just hyperbolic cosine. The derivative of hyperbolic cosine is hyperbolic sine. So what I'm trying to say here is that whenever we were doing regular sine and cosine, I had that the derivative of sine was cosine, but the derivative of cosine was negative sine. So this is from before. This is not new. I'm just talking about your regular sine and cosine functions. These functions, though, behave way nicer. The derivative of hyperbolic sine is hyperbolic cosine, and the derivative of hyperbolic cosine is hyperbolic sine. There's no minus here. So that's kind of the nice part about these hyperbolic functions, is that remembering the derivatives is easier because there's no minus to worry about. So these are just more functions to learn the derivatives of. By definition, these are what they are. So if you ever need to know what is it, like how do I plug it into my calculator, this is the function you would type in. So it's written in terms of your exponential. Those are your two hyperbolic trig functions. So let's do a couple examples here. First one, let's let f of x be hyperbolic sine of 3x. Let's find f prime. So this is not hyperbolic sine of x, this is hyperbolic sine of 3x, so this is a chain. Inside function 3x, outside function hyperbolic sine of x. So what do we say the derivative of hyperbolic sine is? Just hyperbolic cosine. No need to worry about is it minus or anything like that. And then moving up in this ladder, derivative of 3x is just 3. So there's my derivative. Okay, this time let's let f of x be x squared times hyperbolic cosine of 2x. So this is x squared times hyperbolic cosine, so I'm going to have a product. U is x squared, v is hyperbolic cosine of 2x. What's u prime? Well, the derivative of x squared is just 2x. What about the derivative of hyperbolic cosine of 2x? Well, this isn't just an x on the inside, so I got a chain. Inside function's 2x, outside function cosine, hyperbolic cosine of 2x. So just x, not 2x here. Derivative of hyperbolic cosine, hyperbolic sine. Don't worry about a negative, there isn't one. then the derivative of 2x is 2. So the derivative is u prime v, so 2x hyperbolic cosine of 2x, plus u v prime, I'm going to bring out the 2, so 2x squared hyperbolic sine of 2x. So product rule works the same way, we just can find u prime and v prime of more functions now. Let's do one more. Let's let f of x be x cubed minus 2x times hyperbolic sine of x. And let's find the equation of the tangent line at x equals 0. I don't know why I put a space here, just hyperbolic sine of x. Okay, so we're finding the equation of a tangent line. I'm going to move this here. Find the equation of a tangent line, so our answer is always going to be y equals mx plus b. Two steps to go through. First, we got to find m. Remember, m is always the derivative at whatever x value we're looking at. So we're trying to look at x equals 0, so f prime of 0. Let me write down our function one more time. So it was x cubed minus 2x times hyperbolic sine of x. So this is a product, so to find the derivative you got to use the product rule. So x cubed minus 2x for u, hyperbolic sine for v. So u prime, that's just going to be 3x squared minus 2. V prime, hyperbolic cosine. So because it was just an x on the inside, I didn't need to worry about the chain rule. It's just hyperbolic cosine here. So what is f prime? So u prime v, that's going to be 3x squared minus 2 times hyperbolic sine of x plus u v prime. So x cubed minus 2x times hyperbolic cosine of x. So we found the derivative. Next step is we need to plug in 0 because we're trying to find f prime of 0. So if I plug in 0, I'm going to get 3 times 0 squared minus 2 times hyperbolic sine of 0 plus, well, x cubed minus 2x, if I plug in a 0, that's just going to be 0, so this whole second term kind of goes away. So I get minus 2 times hyperbolic sine of 0. Remember, what is hyperbolic sine defined as? This is e to the x minus, e to the 0 minus e to the negative 0 over 2. In the numerator I'll have 1 minus 1, which is 0, so the whole thing is 0. That tells me that m is equal to 0. So here, to find hyperbolic sine of 0, I plugged it into my definition formula. So e to the x minus e to the negative x. So I found m is 0. Next thing I need to find is b. We're going to use the point x, which here is 0, and then f of 0. Now what is f of 0? Let me remind you, since we don't have that up here. The f of x that we're looking at is x cubed minus 2x times hyperbolic sine of x. Now if I plug in 0 to this function, I'll have 0 cubed minus 2 times 0, which is 0, so the whole function is 0. So far, I had that y was 0x plus b, which means that y is just b. So now I plug in my point down here. So I say that 0, which is the y-coordinate, is b. So m is 0 and b is 0, which means the equation of my tangent line is just y equals 0. So to find the equation of the tangent line, didn't do anything differently. Found the derivative, plugged in a point. Found b by using the point that was on the curve. Find m and b and plug them in. Nothing's changed here. The only difference is that we have more functions to take the derivative of.